Okay, here we go, the first recording. This is the first SSE video for the review series for the spring 2019 Math 3 second semester final exam review. We've got this reference document on OneNote to study and the video series to look at on OneNote. But remember, nope, the list is still not all-inclusive of all things you're responsible for studying throughout the entire semester. Prepare yourself for the final exam. What we've got here is we're looking at these two quadratics with the origin there and the origin there. And we're going to try to come up real quick with three quadratic equations that could fit the graph. This was actually, if you remember back, the very first lesson we did in the Carnegie, the new textbook Carnegie with the pages and the binders. You remember those? This was the very first lesson we did on that way back on August 31st. I don't know why I remember that date. Okay? So we're going to try to write down a possible, the scaling doesn't matter, just as long as the numbers fit the kind of things we see. Let's talk about this equation right here. What do I know about the A value? It's negative, that's right, because this is pointing down. What do I know about the y-intercept? It's right there. It's going to be negative. Do I have any x-intercepts? Nope. How about, I think that's all I can say about this one. So actually the best thing to do about this is write it in vertex form, because you can't write one in factored form because x-intercepts don't exist. It doesn't hit the axis. So let's write this in vertex form. Let's see, it has to have a y-intercept that's negative and an a value that's down. So let's say that's negative 2. The vertex is right about there, so that's positive x but negative k. So it would be x minus, 3 squared minus 1. That probably fits that graph pretty well. Makes sense to everybody? If I plug in 0, it's not going to make a negative. Yeah, that's the vertex. That works. Okay? Okay, how about the other one? What am I analyzing on this? What about the a value? What happens to it? It's positive. What about my y-intercept? Y-intercept is negative, and I've got one x-intercept that's positive, one x-intercept that's negative. So right off the bat, I know I can write a factored form and say, x minus 2 for the positive root right there, and x plus 5. That would work. How about vertex form? If my vertex is right there, both of the coordinates are negative, and a is positive, I could just say it's y equals x plus 2 quantity squared minus 3. That would fit that vertex right there. And what about standard form? Could I say, expanded form. Just got to make the y-intercept negative with negative b over 2a. Why don't we just make it this one right here? X squared plus 3x minus 10. Okay? So just being able to analyze a graph and come up with possible quadratics is part of seeing structure. Any questions on that? There's a lot more analysis you guys can do looking at the old notes and looking at the old spot checks, but I leave that up to you. This is just a review. Okay, we got one more question on this video, factoring this expression. I guarantee you're going to see this again. What do I do with this trinomial? How do I factor it? Somebody please tell me something. A times C. But what technique am I using? Magic X. What number goes here? Negative 11. What's 6 times 35? Anybody know that off the top of their head? 210. Man, what a butthead I am. Oh, I know what numbers they are. Can you guys look at those two numbers and figure out what multiplies to 210 but adds up to negative 11? Not 13 and 5. How about 21 and 10? How about 21 and 10? Negative 21 plus 10. Now, if this number is too big for you to do that mentally, remember I taught you guys to start with 210 and make a little factor tree. Start dividing by 1. Start dividing by 2. Start dividing by 3. And do this in the calculator. You got time. Go down and make this factor tree until you find numbers that you can somehow add or subtract and combine them to get negative 11. That's the key. If you did this and you got 10 and you went, oh, 21, those are 11 apart. That's how I know it's this. So now your job is half done. Now that I found my two factors, what do? Divide by the leading coefficient and reduce these fractions. This is divisible by 3, and this one's divisible by 2. Hey, by the way, I realized in teaching another student or talking to another teacher about that right there, look at the leading coefficient, 6. What did I divide by right here? No, what did I divide by? Going right here, I divided by 3, and what did I divide by here? 2. What's 3 times 2? That's always going to work. The stuff you divide by to reduce these is always going to multiply to be your leading coefficient. It has to work that way. That way you can get your binomials to add up correctly. This binomial is 2x minus 7, and this one is 3x plus 5. Look at that. 2 times 3 is that 6. Isn't it cool how those numbers work out? The beauty and symmetry of math never ceases to amaze me. All right, that's it for that one. Ooh, that was a long video.